Hi, welcome back to Science 1206, the motion unit. I'm Ms. Ledwell, and in this video, we'll discuss using significant figures in mathematical calculations. Let's begin. First, let's look at the rule for adding and subtracting with significant figures. For calculations involving addition or subtraction, to determine the number of significant figures to include in your answer, find the number in the problem with the fewest decimal places, as this indicates the number of decimal places to include in the answer. In other words, the final calculation should be rounded to the same precision as the least precise measurement. For example, here we have 42.56 grams plus 39.460 grams plus 4.1 grams. So, in order to figure out the number of significant digits in your answer, we look for the number in the problem with the fewest decimal places. And the number with the fewest decimal places is the 4.1. So the least number of decimal places in the problem is 1 decimal place. Therefore, our answer only has 1 decimal place. Now let's look at the rule for multiplying and dividing with significant figures. When multiplying or dividing numbers, the rule for significant figures is that the number of significant figures in the answer should be the same as the number in the original problem with the least number of significant figures. So notice this time we're not talking about decimal places, we are talking about significant figures. For example, here we have 2.1 centimeters times 3.24 centimeters. The number 2.1 has 2 significant figures, and the number 3.24 has 3 significant figures. So the least number of significant figures in the problem is 2. Therefore, our answer will have 2 significant figures. Now that we've talked about rounding, let's review the rules for rounding. If the first digit to be dropped is below 5, we need to keep the last significant digit unchanged. For example, if we were to round 5.831 grams to 2 significant digits, we notice that the first digit to be dropped is below 5. So 3 is the first digit to be dropped, it's below 5, so we do not change the last significant digit. When we round 5.831 grams, our answer with 2 significant digits will be 5.8 grams. So our rule is, if it's 5 or above, round up. If it's below 5, no change. Let's look at another example. If the first digit to be dropped is 5 or above, we're going to increase the digit before it by 1. For example, round 3.4721 grams to 2 significant digits. The first digit to be dropped is greater than 5, it's 7, so we increase the last significant digit by 1. Our answer then of 3.4721 grams, rounded to 2 significant digits, is 3.5 grams. So again, if the first digit to be dropped is 5 or above, round up. If the first digit to be dropped is below 5, make no change. Now it's time for you to do some practice. Pause this instructional video and grab a pencil and some paper, or open up a blank document on your electronic device. Number your paper or document from 1 to 10. As each problem in the table on the next slides are revealed, write down your answer. We will then review the correct answers one by one. After numbering your paper or document, please resume this instructional video. Our first problem is 23.4 plus 1.252. Pause the video here and work it out yourself, and then resume the video so we can go through the answer together. When you put this in your calculator, the calculated answer is 24.652. But our answer with the correct number of significant figures is going to be different than that. So the rule for adding is that your answer has the number of decimal places as the number in the problem with the least number of decimal places. So in the problem, the least number of decimal places is 1, which means our answer should have 1 decimal place. We also have to remember our rules for rounding. If the number to be dropped is 5 or above, we round up. If it's less than 5, we leave it the same. So our answer is 24.7. Our next problem is 20.5 minus 7.65. If you put that into a calculator, you get 12.85. Our answer here needs to have one decimal place though, same as the least number of decimal places in the problem. And our answer with our rounding rules is 12.9. Number 3, here we're adding three numbers. If you put that in a calculator, you get 122.155. Our answer with the correct number of significant figures needs to have two decimal places, and we need to use our rounding rules. Doing that, we get 122.16. Number 4, here we're adding and subtracting. If you put this in your calculator, you get 7.7711. Our answer needs to have the least number of decimal places in our answer, which is one decimal place, and we need to use our rounding rules to get 7.8. And last, we have three numbers here to subtract and then add. When you put that in a calculator, you get 70.499. Our answer needs to have the least number of decimal places as the number in our problem, which is one decimal place, and we need to use our rounding rules. When we do that, we get 70.5. Now let's try some examples multiplying and dividing. Our first problem, we're multiplying 12.5 times 3.4. Be sure to pause the video and work out the answer on your own, then resume the video and we'll go through the answer together. If you put that in a calculator, you get 42.5. But when we go back and look at the number with the least number of significant digits in the problem, it's 2. So we need to have two significant digits in our answer and use our rounding rules, giving us 43. Number 2, we put these numbers into a calculator. We are going to get 1,835. The least number of significant digits in our problem is 1. So we're only going to have one significant digit in our answer. In order to do that, we're going to need to use scientific notation first. So I've changed that into scientific notation, and then I'll use my rounding rules, and I get 2 times 10 to the power 3. When you use scientific notation, the 10 to the power of part does not count. So our answer, even though it's 2 times 10 to the power 3, the times 10 to the power 3, we don't count that when we count up our number of significant figures. Number 3, if you put that in a calculator, you're going to get 0.003564. Our least number of significant digits is 1, so we need 1 in the answer. Using our rounding rules, we get 0.004. Number 4, we're going to divide. This is the number you'll get if you put this in your calculator. And the least number of significant digits here is 4, so we need 4 in our answer. Using our rounding rules, it's 1,561. And last but not least, we have 99 divided by 1.2. Put that in a calculator, you get 82.5. The least number of significant digits in our problem is 2, so using our rounding rules, we get 83. Now it's time to continue to the next video on significant figures, but before you do that, take a short break. Stretch for 30 seconds and then move on to the next video.